Okay, so today we're going to talk about isosceles and equilateral triangles. The goal for today says to use and apply properties of isosceles triangles. So isosceles triangles are common in the real world. If you look at this diagram right here, it's got a bridge with an isosceles triangle on there, and then there's a diagram with a house that has an isosceles triangle on the roof, so in the trusses. As we work through here, we need to learn about the parts of an isosceles triangle. So on the parts of the isosceles triangle, first of all, you need to fill in isosceles means that there's two congruent sides. And those two sides are actually called the legs of the isosceles triangle. Okay, so the congruent sides are called the legs. If I mark for you like two congruent pieces, okay, so these two pieces right here are congruent. This is called a leg. And this is also called a leg, okay? The other side of the triangle that is not marked is called the base, okay? And what I want you to know is that the base does not have to be at the bottom of the triangle. On this particular one, it is, but we really identify the base as being the piece that's not marked congruent. If I rotate the triangle, the base is no longer on the bottom, so I don't want to think of the base as being the bottom piece. Okay, from here there's a vertex angle, and the vertex angle, it says, is the included angle for the congruent sides. So this angle right here at the top is the vertex angle. It is included between the two congruent sides. So the angle that connects the two congruent sides is called the vertex angle. The last one on here is called the base angles, and the base angles, it says these are the angles that are touching the base. They're the angles that are opposite of the congruent sides. So if I take my triangle and I go opposite of the two congruent pieces, this would be a base angle, and this would be a base angle right here. Those are our base angles. So the two angles that touch the base. Okay, on here, this is just review, naming those pieces from the last slide. So this top angle for this triangle that's between the two congruent pieces, this is what we would call our vertex angle. Okay. These two sides are marked congruent. What do we call those? Those are the legs. Okay, this bottom piece that's not marked congruent is called the base, and just a reminder, the base does not always have to be on the bottom. It's just the piece that is not marked congruent. And then the last piece we have here, these arrows are drawing to these bottom angles, which are touching the base. Those are called the base angles. Okay, isosceles triangle theorem, what it states is if two sides of a triangle are congruent, then the angles opposite of those sides are congruent. So I know in isosceles triangle, I have two sides that are the same. So these two sides are the same. What they're saying is if I go across the triangle to the sides that are the angles that are opposite of those sides, those angles have to be congruent. So like on this triangle, I have two sides congruent. If I go across from my side AC, if this would let me draw, give me just 1 second. Okay, if I go across from my side AC, I'm at angle B. Across from my side BC, I'm at angle A. So what I would say here is angle A would have to be congruent to angle B. The base angles will be congruent. Okay, now there's a converse to this theorem, and if you remember, converse means I take my information and I flip it around. What this is saying is if I have two angles that are congruent, then the sides that are opposite of those angles are also congruent, okay? So I'm flipping around the order of the information. Technically, if I see a triangle with two congruent angles, I can say, hey, that triangle is isosceles, because we know that when we go across from these angles, we're at two sides that have to be congruent. So I'm going to have AC congruent to my side length CB. All right, moving on. The bisector of the vertex angle of an isosceles triangle is a perpendicular bisector of the base. Okay, so there's a lot going on right there. What it's saying here is that this line right here bisects this vertex angle. And the reason, or the way I can tell that it bisects it, is that these two are marked congruent. Now what it's saying is if there's a bisector, an angle bisector of the vertex angle, well, this is also going to be considered a perpendicular bisector. So the perpendicular piece means that when CD meets the base, it's going to form a right angle. So I'm going to mark these 90s. It's also going to bisect the base. So I'm going to mark that AD is congruent to DB. And that's what they mean by perpendicular bisector. It bisects the base. So it's bisecting a segment. Not this angle up here, bisecting the base. Okay. A corollary to the theorem, it says if a triangle is equilateral, then it is also equiangular, okay? Equilateral, once again, means that all three sides are the same, okay? Now, if you think back to that isosceles triangle theorem, if I go across the triangle from these two sides, that means these two angles are congruent. But since I have a third side that's congruent, that means this angle here would have to be congruent as well. So we're going to say angle X would be congruent to angle Y, and it's also congruent to angle Z. They're all the same, okay? Now on the next one, it's going to be the converse of that corollary. It says if a triangle is equiangular, then it is equilateral. So using that same idea that if I have three congruent angles, if I go to the opposite sides, these are congruent, going to this opposite side would be congruent as well. So I'm going to say XY is congruent to YZ, which is congruent to XZ. Okay, getting to a proof here. So it says M is parallel to N. I'm going to mark that on my diagram with those arrows. And then from there it says angle XAB. So if I kind of trace for you, XAB is congruent to angle C, which they have marked for us on our diagram. We're going to write it in. So M is parallel to N. Angle XAB is congruent to angle C. And my reason, this is the given. Okay, changing colors. Step 2, I'm going to play off of these parallel lines right here. So if the lines are parallel, what I have is a pair of alternate interiors. I have this angle XAB would be alternate interior to this angle down here. So on step 2, I'm going to say angle XAB is congruent to angle ABC. And my reason would be if lines are parallel, then alternate interior angles are congruent. Okay? From there, what I have is I'm trying to prove that this triangle, trying to prove that this triangle is isosceles. Okay? Now, when I look at this triangle right now, what I see is that these two angles are congruent. I haven't stated it over here, so that's going to be my step 3 of my proof. It's just identifying that I have some congruent angles in there. So step 3, I'm going to say, well, angle ABC is congruent to angle C. And this is just going to be, I knew XAB was congruent to angle C. I knew that it's also equal to ABC. So I'm going to state that they're congruent. This is substitution. So I'm just replacing angle XAB with angle ABC. Okay? From there, if I'm able to establish that I have two congruent angles, so these two angles congruent, then I know that the sides opposite of them are congruent. So working in this triangle, I know AB has to be congruent to AC. So I'm going to state that for my step 4. I'm going to say that segment AB, put that segment notation over the top, is congruent to segment AC. And my reason is going to be the isosceles triangle theorem, but this would be the converse. And the reason it's the converse is because we started with the congruent angles and then went to the sides. So we're using the converse of the theorem. Okay, from there, now I have enough information to prove that my triangle is isosceles because I've showed that these two sides are congruent. So I'm ready to prove it. I'm going to say in step 5, triangle ABC is isosceles. And my reason is just going to be definition of isosceles triangle. Okay, I proved that two sides are congruent. That means it has to be isosceles. All right, here we go. So working through some example problems. On this diagram right here, it says, suppose that the measure of angle L is y. Find the values of x and y. Now I need you to update your diagram. On yours, I believe that this top angle over here is labeled as y, so cross it out, right, 42.5, and then we're going to talk about it. Okay, now one thing that I can tell from this diagram is that OM is an angle bisector, and the way that I can tell is that the two angles at the top are congruent. Okay, we said that if there's an angle bisector for that vertex angle, then this line is also a perpendicular bisector of the base. Perpendicular meaning this is going to be 90. So I can say x is equal to 90. I also know that it bisects the base, so I can mark these two pieces congruent to each other. Okay, if I look at the triangles then, if I have 90 on one side, I have to have 90 on the other side. I'm going to highlight just this triangle right here. And what I see is that I have this 90-degree angle. This angle up here would be the same as the other two, so it would be 42.5. Okay, and I'm trying to find angle Y. So my triangle has to have a sum of 180. And from here, I'm going to subtract 90 plus 42 gives me 132.5. And if I subtract those, I'm going to be left with 47.5, and that's going to be my measure of angle Y. Okay. All right, these are just working with that isosceles triangle off to the right. So it says if the measure of angle BAC is 38, they want us to find the measure of angle C. Okay, working on this triangle right here, since it's isosceles, this side is across from, well, this side's across from angle C. Our side AC is across from angle B. Those angles have to be congruent. I know in a triangle there's 180 degrees. And if I subtract the 38, what am I left with? 142. Well, that 142 has to get split between the two base angles. So if I divide by 2, each angle is going to measure 71 degrees. Okay? If I work on a new problem, then I need to erase this information and start over. So now I'm going to start with problem number 2. And it says angle BAM, so this angle here, is congruent to angle CAM. And it's telling me that each angle is going to measure 23 degrees. Okay? They want me to find the measure of angle BMA, so this angle right here. Okay? That theorem stated that if I have a line that bisects the vertex angle, this line is also a perpendicular bisector. So what type of angles do I get down here? They should be 90. Okay, so 90 degrees. Now, if I don't recognize that theorem, I can still get through this problem. I could use what we did in the last problem. I could say 180 is the measure of my triangle. Subtract what we already have. So the 23 and the 23 would give me 46. That's going to leave me with 134. Now, if I take 134 and I divide by 2, what am I going to be left with? I'm going to be left with 67 degrees. Okay, now what that would mean is that this angle is 67 and this base angle has to be congruent to this base angle, so it would be 67. And then from there, I could split it into this smaller triangle and say, well, if I take 180 and subtract this 67 and the 23 together would equal 90, I'm left with 90. So either way, I'm going to get 90 for my answer. It's just if you remember that theorem about the angle bisector being the perpendicular bisector. Okay, last problem. So we are going to erase this information and start new. Okay, and on this last one, what it gives us is the measure of the angles. So if we fill them in, angle B is going to be 3x. This angle BAC, so the vertex angle is going to be 2x minus 20. We know that if it's isosceles, the two base angles are the same, so across from those sides. So this angle and this angle are the same, so this one's going to be 3x. And I know that all three angles of my triangle have to total to 180. So I'm going to say 3x plus 2x minus 20 is equal to 180. If I add those values together, I get 8x minus 20 equal to 180. How do I get the 20 to the other side? I would add it. So now I have 8x is equal to 200. And if I take 200 and divide by 8, I'm going to find that x is equal to 25. And there's my final answer. Okay, this problem right here is very interesting. What we're looking at is the angles, and I have this angle that's 60 right here, and then I need to find some of the other pieces. Okay, first thing it asks me to find is x, and I see that this triangle in the middle is isosceles, and that tells me that this angle here would have to be congruent to this angle here. So to get started, I can say my triangle is 180 degrees. I already have 60 degrees in that triangle, so I'm left with 120. Now that 120 has to get split between these two angles right here. So I'm going to take 120 and divide by 2. I'm going to find it to be 60, and that's my x value. Okay. Now if you look at the other triangles, are they marked similarly? Here I have a vertex angle of 60. I know that these two sides are congruent because if I go across from those angles, then those two sides have to be congruent. So that's isosceles. I'm really going to get the same relationship over here in this triangle. Now, if I'm getting 60 and 60 and 60 as my angles, technically it's not just isosceles, it's actually equilateral, okay? Because all of the angles are the same, that means all of the sides are the same. So equilateral in this triangle up here as well. So I'm going to take this 18, which is this full measure here, and cut it in half. So 18 divided by 2, I'm going to end up with 9 here. 9 here, this side is 9, this side is 9, this side is 9, this side is 9, this side right here. So y is going to equal 9. Okay, this problem we're crossing out. Everyone say, yippee skippy. Okay, moving on to number 8. On number 8, it says, suppose the measure of angle L is 63 degrees. They want us to find the values of x and y. Okay, so going back to that theorem that we've talked about a couple of times, I can see that these two angles here are marked congruent, and what that tells me is that MO has to be an angle bisector. If it bisects the vertex angle, we said it's also the perpendicular bisector of the base. So once again, perpendicular means it's going to form a 90 here. So my x is equal to 90. Okay, this base is bisected, so I'm going to mark those congruent. The last thing I need to do is figure out, well, what's my measure for y? I could fill in 90 right here on my other triangle. I know that this top angle is y. I could put y here. So now if I just work with this triangle, I have two angles of my triangle. The sum of the triangle is 180. I need to subtract, if I take 90 plus 63, I get 153. And if I subtract there, I end up with 27 degrees. So my y is equal to 27 degrees. Okay. All right, that's all for today. So worksheet is 4.5. You should be able to grab that from your sub today. Bye-bye.